And welcome to our YouTube viewers. This video is dedicated to all of our viewers who've been with us for years and years. SDO data's back, baby. We've got at least 3 sunspot groups in the offing. One just setting up here in the northwest. These 2 are still substantial sunspots. They are beta-gamma class sunspot groups, more likely to produce X-ray flares than simple alpha class sunspots. And some more groups back here as well. Solar activity a bit on the low side. Here's your colorized magnetogram to show mostly stable sunspots over the past 24 hours. And let's add 171 angstroms to show, oh my god, what is going on here? It must be an alien spacecraft, or maybe CERN has turned back on. Just kidding, folks. It's the moon getting in the way of the SDO and affecting the magnetometer data, it looks like. That's colorized magnetogram plus 171 angstroms. Radio flux down to 96 solar flux units. And for those of you not familiar with the 10.7 centimeter radio flux, it's the most proportional data set that we have to sunspot number. In other words, it's indicative of solar activity. And there you can see how proportional it is to the sunspot number there, which is the red line. The black line is the 10.7 centimeter radio flux. Again, we're at 96 solar flux units. No geomagnetic unrest or geomagnetic storm conditions forecasted by NOAA. We'll get to the solar wind momentarily. This is an all-inclusive video. We've decided to put everything together today for YouTube. Seismically, we are seeing an earthquake drought. Only 2 7-magnitude earthquakes in the past 90 days, and we're about to be down to 1. The last 7+ magnitude event happened on the 26th of May in southern Peru. We've seen a small uptick since yesterday, however, no big quakes. I think the largest quake of the past 24 was that 5.4 at Taiwan. Remember, folks, any earthquake can be a foreshock. If you're in an earthquake-prone zone, please have an earthquake plan. If the power goes out and the buildings begin to collapse, know which ones may collapse. That could help you out vastly. It could help you to be an asset, not a liability, in the event of a disaster. So there were a couple 5+ magnitude quakes there, but pretty calm seismically speaking. Remember, folks, any earthquake can be a foreshock. Now looking at volcanoes real quick. Sakurajima producing an 8,000-foot plume of volcanic ash over the Japanese island of Kyushu. Krakatoa now back on the list, exploding, flight level 070 over Krakatoa in the East Sunda Strait. Semeru exploding. There's an uptick at Semeru. That's a 17,000-foot volcanic ash plume, flight level 170. Tucono exploding, flight level 070 over Tucono. And moving to Central America, we see Fuego is erupting in an explosive fashion. 15,000-foot ash plume from Fuego over Guatemala. Nevado del Ruiz, 21,000-foot ash plume as Nevado del Ruiz explodes in Colombia. Ecuador seeing 2 offenders, Sangay and Revenador. Sangay exploding to a 22,000-foot plume of volcanic ash. Revenador, a 15,000-foot plume of volcanic ash. Please don't pole vault the caldera. And Sabancaya rounds out our list with some explosive activity, emissions to 22,000 feet. It's a flight level 220. And let's take a look at some 2-day SDO data here, moving back into the realm of space. A frontier. These are the voyages of the SDO, viewing the sun in 131 angstroms. A great wavelength for solar flares, and we've seen pretty calm conditions for solar flares. We'll get to more in-depth information about that momentarily. Space weather includes Earth and Sun. So let's look at the Earth geospace for the past 4 hours. There is your magnetohydrodynamic pressure surrounding the planet, and since it refreshed, we're going to let that play through. So we do see a slightly elevated solar wind. We saw some minor glancing blow coronal mass ejection impacts. Those occurred yesterday. We'll get to that when we look at the real-time solar wind data. Once again, that's the last 4 hours of Earth's geospace. Earth's magnetic moment from space to about 12 Earth diameters. Next Earth's magnetic moment from the ground, also the past 4 hours. And let us know in the comments what coffee you're drinking. Today we're having organic Mexican Chiapas. Again, that's the last 4 hours of Earth's magnetic moment from the ground. Things pretty geomagnetically calm here at the moment as we're seeing the end portions of a coronal hole high-speed stream. KP index is at 2. Again, geomagnetically calm conditions here. The planetary K index is a measurement of global geomagnetism. Now moving to the real-time solar wind. You can see this time right here we saw some pulsating coronal mass ejection strikes. We did see the density make it up to about 30 protons per cubic centimeter there. And you can see the plasma temperature rose there and the plasma speed dipped at that same moment. You can also see a shift in the phi angle, which is the blue line. Besides that, things pretty consistent here over the past 24 hours. Current conditions are about 5.3 protons per cubic centimeter for the solar wind density. Solar wind speed just under 500 kilometers a second at 491. There are your GOES magnetometers for the past 3 days. And those are smoothing out a little bit as, again, coronal hole high-speed stream plasma is subsiding. Now let's look at the heliospheric current sheet. The plasma of the current sheet is oriented to a pole. Earth is currently in a south pole current sheet. Keep in mind the data was 1 hour and 36 minutes old when we recorded the video. Now let's take a look at the line of sight field plot. Here's your solar magnetogram. The sun's B field shown there in blue. North solar polar field shown in green. South solar polar field shown in red. And you can see those fields are in the process of migrating to their opposite respective poles. Next, coronal holes. And we've got south pole oriented coronal holes here facing Earth. A couple decently well-defined ones. North pole coronal hole there still hanging out around the North Pole, at least on this side of the sun. So we've brought up 211 angstroms as the coronal holes are a little better defined in this wavelength. And you can see some plasma reorientation activities happening right here in the north central portion of the solar disk there. And some pretty well-defined coronal holes here rotating in from the east. That's the last 48 hours from the SDO, 211 angstroms ionized iron. By the way, if you are not familiar with the Smash Team website, Smash staff just optimized it to get you a little faster page loads. Smashamash.com/SmashTeam. Join at the gold or silver level if you'd like to support the channel. Thanks to everybody who has. Did you know we regularly stream live to Twitch? We did about 20 hours of streaming in the past 24 hours. So check us out over there also, twitch.tv/SmashAmash. Today's featured product is Mensa. Here at the Smash News Network, least busted name in news. We're trying to make Earth not suck again. We're doing our part, putting out videos, citing a bunch of facts, and trying to advance the science of heliophysics. Make Earth not suck again. It's up to you. Check out the other 50 products available with the fresh design. It's up to you to make Earth not suck again. Tell your friends and foes about us. Pick up some merch. Help support the channel that way. Give Smash staff a raise. And don't forget to press like and subscribe if you enjoy the content on YouTube. This has been an all-inclusive, exclusive YouTube video. You can also find our links on the homepage at smashamash.com, and welcome to the Neo Renaissance. Smash staff made some changes over here as well, thanks to Smash staff. Smashamash.com. Welcome to the Neo Renaissance. Let's move into the realm of sunspots. More facts coming at you. Most likely places to see flares would be from this area right here, 3041. Also 3040 and 3042 are both beta-class sunspot groups. And there are some more minor sunspots back here, a little bit on the eastern portion of the solar disk. Let's take a look at it in the 1700 angstroms. Let's blow that up a little bit. There's 75% zoom. That's the last 48 hours from the SDO. Thank goodness it's back. We're delighted that Stanford University is no longer experiencing a power outage. Continuing on to our solar magnetogram. We'll zoom out a little bit there to show the magnetogram from El Teide, Spain. Again, sunspots have been mostly stable here over the past 24 hours. Here is your intensitygram, also from El Teide, Spain's ground-based solar observatory. And let's move on. So, solar flares have been quite minor. If you look at the 7-day chart, you can see a diminishing of the X-ray profile of the closest star. Yeah, you're orbiting a star, and thanks for stargazing with the SMASH team. No spikes in the proton flux there, no major flares, and a great wavelength to view flares would be 94 angstroms. Likelihood of major flares not all that high, but the most likely places again are 3041, 3040, and whatever this one's called, 3042. And we've brought up a star chart here. We're always interested in what's going on above our heads. I'd like to face mine to the south. That's the direction of the ecliptic from the northern hemisphere location at which we reside. So that's what's going on over Lehigh Valley, Pennsylvania. Saturn, Jupiter, Mars, Venus, Mercury. The moon rising behind the sun today. A little tiny sliver. You'll barely be able to see it. It's new moon day. Yesterday and today, I'm not sure when the moon was the newest, but it's pretty new at the moment. Our favorite phase, we hope you're sleeping well at night, along with the rest of you reverse werewolves. Let's advance this 1 week as Mercury and Venus break the pattern here, moving to the opposite side of the solar system. There's where things will be in a week, and all the planets are not going to continue to remain on one side of the sun as Mercury and Venus are blowing past everybody else. Take a look at our coronagraph. This is the coronagraph just from today. Great detail there. And let's look at some additional imagery here from the Stereo A Core 2 Space Weather Beacon and the SOHO LASCO C3 shown here on the right. Nothing too exciting going on as far as coronal mass ejections. We cover it daily, so you know you're getting the full extent of the data. Don't worry, we've got more imagery of the sun. Here's the last 2 hours in 304 angstroms from the GOES 16 SUVI. If we do see additional CMEs or coronal mass ejections, we can expect them to be spectacular from this wavelength. That's ionized helium. And we'll close out the space weather portion in the higher resolution SDO imagery in ionized helium. Just spectacular imagery there. Thank goodness the SDO is back. So here at the Smash News Network, Least Busted Name in News, we implore you to continue watching as we are moving to our meteorology segment next, right after our bonus feature segment. So we're starting things out with the total electron content forecast. This video often only appears on Twitch. Twitch.tv/SmashoMash is the URL. Go install the mobile app. It'll actually alert you when we go live, unlike some streaming applications. That's the total electron content forecast for planet Earth. And the total electron content kind of low, even though the GOES electron flux kind of high. Total electron content is showing you the coupled thermosphere, ionosphere, plasmasphere electrodynamics model. And in between your GPS satellite and your handset, there's about 12,500 miles of distance. You've got a plasmasphere up here. You've got a Van Allen belt here. You've got another plasmasphere below the inner Van Allen belt, and then the ionosphere below that. And that's what the total electron content forecast shows. It shows the free electrons in all of those areas. Next, satellite charging hazards. We are seeing some internal and some surface charging hazards. Those are the locations of those. southern Indian Ocean for internal charging hazards, and moving into the Central Pacific for surface charging hazards. They are all somewhat minor. And here's your GOES electron flux. Now the GOES 16 and 17, they measure the electron flux at the F ionosphere layer. So they're in a geosynchronous orbit of about 10,500 miles of altitude, and they use radiography to measure the electron flux at the F ionosphere layer, down at about 300 kilometers of altitude. And we're seeing high levels of electron flux at that level, the F ionosphere layer. Here's the forecast model, and NOAA forecasting even higher levels. I would not argue this time, as I've been incorrect the past couple days with my expectation of a dip in the electron flux. No arguments today. That's the NOAA forecast. There's the one-year chart to put the electron flux in context. And next we'll show the F ionosphere layer to show the vibrational frequency and anomalygram. So first the vibrational frequency, which you have here. All this data is courtesy of Australian Government Bureau of Meteorology, if you're wondering. And that's what's going on in the F layer. Here's the anomalygram for the F layer of the ionosphere. This is anomaly in megahertz from the 30-day median. And you can see mostly low-frequency anomalies showing up there in red. And if this part of the world looks kind of weird, that's because that's the South Atlantic anomaly now over the South American continent. That is the weakest point in Earth's magnetosphere. So here's the latest image. That's the ionogram from 10 o'clock Universal Time. There's the anomalygram from 10 o'clock Universal Time. We're going to show a ground-based solar observatory, as we do when we stream live to Twitch most days. Here's hydrogen alpha from El Teide, Spain. Lots of filaments here on the Earth-facing side of the solar disk. You can see all these dark absorption features. Those are all filaments. These bright prominences that hang out over the limb, those are also filaments. Lots of plasma capable of ejecting. Remember, folks, you don't need sunspots or solar flares for coronal mass ejections to occur. Next, your latest intensitygram and latest colorized magnetogram. We show the refresh so you know you're seeing the latest data. We've got some additional umbrae there around sunspot 3040. That's beta gamma class as well. We've got some more sunspot groups forming there in the east. Here's your colorized magnetogram. And of course you can see multiple umbrae there. That's our largest sunspot at the moment. And this North Pole oriented magnetic field makes that indeed a beta gamma class sunspot. We'll close out the space weather segment with 171 angstroms from the SDO, the house favorite wavelength. And once again, we would remind you not to tune out from the Smash News Network least busted name in news. We'll continue on with our meteorology segment. Again, today it's an all-in-one video. Now we're looking at the surface winds of the eastern world. So that's what's going on as far as surface winds. Here are the jet streams of this side of the planet. Pretty strong jet streams here over most of Australia. Pretty incoherent jet streams in the northern hemisphere of that part of the world, and you can see it is blowing backwards once again over the central Indian Ocean. Here are the jet streams of the Americas. Once again, the jet stream largely staying north of the U.S. and getting some cold air down into Pennsylvania. Again, once again, a pretty cold morning here in Lehigh Valley. Here are the surface winds of the Americas. And one last view here, it's Europe, Africa, and the Middle East. There are the surface winds of that side of the planet. There are the 250 hectopascal winds known as the jet stream. And we've got a strong anticyclone here rotating counterclockwise in the southern hemisphere around the coastline of southwestern Africa. And it looks like a cold day for Portugal as we're getting some Arctic air blowing straight down to the south. Maybe similar weather to Pennsylvania today in Portugal. Here's your weather.gov map. If your county's lit, click your county. We've got some small craft advisories, brisk wind and hazardous seas warnings around Hawaii. Could be another great day for surf. Drop us a line on Instagram if you're into it. We will show your footage if you've got imagery of big waves, or if you've got anything else you'd like to cover. Feel free to drop us a line on Discord. There's a permanent invite link on the smashomash.com homepage. Next, looking at lightning. Here's your lightning mapper from the NASA GOES lightning mapper. Quite active lightning here over lots of Mexico. Almost all of Mexico there, seeing some lightning. Yowzers. And let's check a real-time lightning map. We won't spend too much time on lightningmaps.org, but if there is terrestrial lightning, we will call it out. Galveston. There is some active lightning all around you at the moment. Galveston, Texas, seeing some active cells. Next time you hear thunder, check out lightningmaps.org. It could save your bacon from being pre-cooked or being partially cooked. Who wants that? Next, your 72-hour GFS pressure. This is your temperature anomaly forecast. GFS 72-hour temperature anomaly forecast. It is in Celsius degrees. Looks like a lot of cold weather here over the central U.S., the southern Rockies. High temperature anomalies a little bit less common here at the moment in the U.S. We'll also show the 72-hour GFS pressure and precipitation forecast. Again, we're expecting some powerful concentrated cells in the southern eastern portion of the U.S. So the Gulf states, all expected to see some powerful storms there. Galveston, you're going to get hit a couple extra times here, it looks like. Again, that's a 72-hour pressure and precipitation forecast based on the GFS model. And here's your pressure map from windy.com. Windy.com's got a great mobile app. Perhaps install that if you like. Windy.com, we're not paid to say it yet, could be a future endorsement for the channel. It would be appropriate for all the things that we do. Next, looking at your all 50 states U.S. Doppler radar map at radar.weather.gov. And we'll focus on the lower 58 for the remainder of the video. There's your U.S. Doppler. Here's your shortwave radiation map showing clouds and fog. You can see some rapid cloud nucleation happening here south of Louisiana. And here's the water vapor map to corroborate that. Some hot water and some convective forces happening. Also some sudden cloud nucleation over Georgia. And some dry, massive air moving southeast over the central portion of the U.S. That is a high-pressure zone, and clear skies are likely overhead. Here's your recap to close out our Daily Space Weather Plus Meteorology segment video. Meteorology, it was too easy, so we decided to add space weather, a little bit more challenging. Here's the second last portion of your recap. Clouds and fog, 3.9 nanometer infrared radiation. And here is water vapor. That should be pretty definitive. And if you're able to forecast your weather as a result of watching our videos, let us know in the comments, as we appreciate people learning new things. Of course, remember, folks, ignorance is the root of all knowledge. In any case, thanks for tuning in to the Smash News Network, least busted name in news, and may that solar wind be at your back.